Welcome to Pomodoro Joe for Wednesday, February 22nd, 2023. Today we're looking at LeetCode problem 1011, capacity to ship packages within D days. This is a medium problem. And the problem statement says, a conveyor belt has packages that must be shipped from one port to another within days. The ith package on the conveyor belt has a weight of weights I. Each day we load the ship with packages on the conveyor belt in the order given by weights. We may not load more weight than the maximum weight capacity of the ship. Return the least weight capacity of the ship that will result in all the packages on the conveyor belt being shipped within D days. Okay, that's a tough one to wrap your head around, but basically we're given an array that represents the weights of packages, and we have to pack them onto a ship in the order that they appear in the array. And we can pack as many or as few packages per ship as we want, but we need to be able to get all of the packages delivered within days, in this case 5 days. Which means that we basically get 5 shiploads worth of packages. So we have to divide this array into 5 segments, minimizing the weight in each segment. Wow, this is a tricky one. All right, let's see what our constraints are here. We have at least 1 day, but we also have up to 5 times 10 to the 4th packages. That's a lot of packages. Okay. So my initial thought would be to do this recursively. But before we jump in, I will put 25 minutes on the Pomodoro timer and we will get started. Okay, so my initial thought is recursion, but I am a little bit skeptical that this will pass in time, but let's give it a shot. So with the recursive algorithm, we're going to need our base case. And I think in this case, we just say our base case is we just have 1 day left. So if we only have 1 day, then we have to ship all the packages on one ship, which means we just return the sum of all those weights. So if days okay, so that's our first base case. We only have 1 day. We just have to ship everything. What other cases do we have? Well, this might be a little bit early to optimize, but I'll do it anyway. If we have fewer packages than we have days, then we can just return whatever the heaviest package is. So let's see, the length of our weights is less than or equal to days. So that means we can basically just ship 1 package a day, and in that case we just find the heaviest package, and that's the lightest ship weight we can have. So that's going to be the max of our weight. So that takes care of 2 base cases. Now the remaining case, this is where we say, well, let's take the first package, put it on a ship, and then let the rest get shipped out on other days. Or we could take the first 2 packages, put those on a ship, and let the rest get shipped out on other days. Or we could take the first 3 packages, 4 packages, so on and so forth. So this requires a lot more processing than I think I want, but we'll just see if it works. So essentially we'll just say for 1 package all the way up to the length of our packages, we'll just pack that many onto this ship and let the remaining packages get shipped out on other days. So let's see, I'll have package weights. I'll call this total weight. All right, so the total weight will add each package to the total weight. So we'll add the weight of this new package, and then let's see, the remaining packages we'll ship those on other days. So we can just call self.ship within days. And let's see, that'll be weights from I plus 1 to the end, and days minus 1. So in this case, we're just going to take the rest of the packages, so that's this weights I plus 1 to the end, and take away 1 day because we're going to ship this total weight today, and then all the remaining on other days. All right, I guess I need a result here. So let's have some result. And we'll set it to infinite to start with. We need a really big number because we don't know how many packages we need to ship. So we'll just say our boat has to carry all the packages. I could say this is actually sum of weights. Maybe I'll do that. Let's just say it has to carry all the packages. Okay, so now if our total weight, so that's what we're shipping today, versus our remaining days, whichever one of those has the maximum value, that's going to have to be what we compare to our result. So let's see. Our current option is the maximum of either this total weight that we're shipping today, or whatever the best answer is from our remaining days. And then our result will be the max of those, or no, sorry, the min of those. The min of result, or the option that we found that might be better than our current result. All right, and then at the very end, we can return our result. So this is the recursive solution. Let's see if that works. I see. I don't need to go to the length of weights. I want to go to length of weights minus 1. We need to have at least one package to ship on any given day. Okay, let's try that again. Okay, so it works. Recursive, not too bad. Let's see if we can pass. Ooh, not even close. We only pass 11 out of 85 tests before we run out of time. Now, normally I'd say, well, we can break this out into a smaller problem. We can use some dynamic programming to hold some of these values so that we don't have to recalculate. But 11 out of 85 is so low, I don't think optimizing this solution will really be a viable option. Okay, so let's start over. Let's think about this a different way. Okay, so I still like these base cases. In the worst case, we have to just ship all the packages on one day. So that's going to be the sum of our weights. So instead of checking the day, I'm just going to call this like our max weight. So the max weight that we'll ever need to ship will be the sum of all of our weights. And same thing here. I'll call this the min weight. And the min weight will be just the maximum package weight of any individual package. So we can't go for anything less than that because we need to be able to ship at least the heaviest package. Okay, so we have a max weight and a min weight. What if we just search all the different weights in between, go from the min to the max, and just say which one, actually we don't even need to go to the max, we can just start at the min and start working our way up until we find the weight that lets us ship all of our packages. I like that actually. So let's do that. So we can just say we have some result and it'll start at the min weight. And we can just say, while we're not able to ship packages, with, let's see, ship capacity. That's too long. let's just call it, let's call it not acceptable capacity. Or weight limit, let's do that. Let's call it acceptable weight limit. And we'll have our limit here. So while we don't have an acceptable weight limit, we'll just increase our result by 1. And we can just pass in our result here, and we'll return our result at the end. So as long as we don't have an acceptable weight limit, we'll just keep increasing it by 1. We'll start at the min possible weight, increase it by 1 each time. Okay, we'll start our result at the minimum possible weight. So that's a single package of the heaviest package we have. And then we'll just keep increasing that weight little by little, essentially 1 by 1, until we find the weight that lets us ship our packages in the given number of days. Okay, so now we need to implement this acceptable weight limit. Let's try that. I'll call this limit. Okay, let's see. How do we calculate if this weight limit will let us ship all of our packages? I think we need to go through all of our weights, add up the packages until we exceed the limit. Then we can just say that's 1 day's worth minus that last package that caused us to exceed our limit. And we'll keep adding days. Hopefully this will make more sense when I start typing. All right, so we'll have a day count. And we need at least 1 day to ship packages. And then let's see, we need our current weight, or our package weight. I'll call it total weight. How about that? Or I'll call it day weight. I like that. So the current day weight is going to be 0. And then for every weight in our weights, we'll just say our day weight plus that weight. So we're adding, maybe I'll call it boat weight. Whatever. So we're just saying for this day, we're adding this weight to the boat. And if at some point our day weight exceeds our limit, we can't add this package on this day. So if the day weight is greater than our limit, then we need to basically hold that package for the next day. So we'll increase our day count. We've reached our capacity on this day, so we have to wait till the next day. And then our day weight for the next day will start with this packages. We'll start with this weight. And then at the very end, we can just say we'll return is our day count less than or equal to our days. So if we can get all the packages shipped in fewer days than the allotment, then we're good to go. I feel like I'm missing something, but let's give that a shot. Don't need that. All right, try that again. And we are undershooting. Let's see what's going on here. We have our day count. Oh, I have my indentation wrong. That was a silly mistake. There we go. Let's try that one. All right, we pass. Let's see if this will pass all the time limits on the full submission. Time limit exceeded, but we are closer. 75 out of 85. Okay, so we have a basic algorithm that kind of works. We're not quite getting there in time, so we can do some things to save some time here. We don't need to keep calculating if we already know we've passed our day count, so we can do something here. So as soon as we increment our day count, let's just check. our day count is greater than or equal to our days. Now, if it's equal to, we still have a package that we have to ship the next day, so we'll have to return false. Then down here, we don't have to do this comparison. We can just return true because we've made it past all of our day checks inside here. All right, let's see if that works, and maybe that'll give us just enough boost to get past all the checks. Oh, that doesn't work. Maybe I do have to check just greater than. Really? All right, let's try that. Oh, a little bit closer, 78 out of 85. Okay, so clearly, well, I guess we're not actually using this max weight. Maybe we can save enough. Let me just comment this out, because I have a feeling we'll be wanting this sooner rather than later. Let's try this. By not running that sum, maybe we'll save enough. Nope, didn't save us anything. Okay, so what can we do to speed this up? Well, what we're doing here is a linear search. We're basically saying we're starting at the minimum and we're working our way up from the minimum. What if we didn't work our way up from the minimum? What if we bounded our search parameters and did a binary search? I think that might save us enough. So that's going to take us back to, we've got our max weight and our min weight. So our max weight, again, is just we ship all the packages on one day, and our min weight is just the heaviest package we've got. So our optimal weight has to lie somewhere in between those two. I think we're still going to want this acceptable limit. Let's change this result, and we'll change this while loop. So now this becomes a binary search problem. And if you've watched some of my other videos, you'll know how we do this. We will start with bounding our search area. So we'll have a lower bound, and that's going to be our min weight. And we'll have an upper bound, and that's going to be our max weight. Okay, now while our lower bound is less than our upper bound, we'll find the midpoint. What's in between the upper and the lower? Well, that'll be lower plus our upper minus our lower with an integer divided by 2. So this basically splits our search area in two halves, an upper half and a lower half, with mid being right in the middle. All right, so now we can say, what do we call this? Acceptable weight. All right. So now we can say, if we have an acceptable weight limit at this midpoint, that means we were able to ship everything at this midpoint. We're looking for something that's smaller than this midpoint. We want to find the lowest possible acceptable limit. So in that case, let's lower our upper bound to this midpoint, because we know that we can ship everything with this midpoint. So let's go to the midpoint. Actually, we can go midpoint minus 1. Is that right? No, I think I need to stick at the midpoint, actually. Otherwise, we can increase our lower bound to this midpoint plus 1. Let me think about this for a second. I might be getting these switched around. I actually think, all right, so we have our midpoint. We're able to ship at that midpoint. Anything above that will be excessive. We don't need to find a higher midpoint. So we definitely drop this down to the mid. Now, if we have a lower bound, we weren't able to ship, which means our midpoint is not acceptable. So we have to do lower bound plus, we have to do mid plus 1. All right. And then at the end, we will return our lower, upper. They should be the same by the time we finish our binary search. All right, let's see if that still works. Still works. Let's see if this will get us any gains. Oh, and we do pass. Not a very good algorithm. We only beat 23% for runtime. We beat 97% for memory. Okay, that's pretty good. But at 23% runtime, not my favorite. And we had all these time limit exceeded. This one seems like a harder problem than a medium problem. All right, is there anything that we can do to optimize this guy? One thing we might try doing is, so this max weight might be excessive. Like if our days, actually that might be something we can do. So our max weight is just saying we only had one day, we have to ship all these packages on one day. But we don't usually have one day, we have a certain number of days. So we might be able to reduce this max weight down to say, let's just say we have to ship all of our packages on average by the sum of the weights divided by our days. So this may cut down our search by a significant amount. So if we still only had one day, it would be the total sum of all the packages. If we had 2 days, then on average we'd have to ship half the packages on one day and the other half on the other day. I'm a little concerned that this might not work 100%. I'm willing to give it a shot though. Okay, that's not going to work. So this is giving us the average that we have to ship. What can we do to reduce this max? I'm going to move it down because I have a feeling if we did something like yeah, there's got to be a better maximum. Well, I think I'm going to have to leave it here. I'm down to 1 minute left. So we did pass. It's not a great algorithm by any means. You have lots of room for improvement on this one. So I totally encourage you to check this out. This is LeetCode problem 1011. Check it out on your own. Hope you had fun. Hope you enjoyed this. Hope you learned something. Hope you can write better code than me.